Hi, I'm Rachel Edmonds, and today I'm going to be talking about building number sense with mental math strategies. So, what feeling does that bring to mind when I say mental math? I know for me, growing up at least, I had this idea that if you were good at math, that meant you were good at mental math, and that meant you had to be fast. And even though I did well in math, the idea of doing mental math kind of gave me some anxiety. I thought if I don't get an answer quickly, that must mean that I'm not smart anymore. But I've come to learn that that's not the case, that mental math is something you can learn, that anyone can learn if they practice it, and it is something that is beneficial to teach our students. I stopped looking at mental math as a way to measure intelligence and instead a way to build intelligence. So that's what we're going to talk about today and get into some strategies and some things you can do in your own classroom. Today we're going to discuss what is number sense. We'll go over some strategies. We'll describe thinking versus memorization, how to implement some of these strategies in your class, and what we expect for the end results. So let's get right into what is number sense. Number sense is what students develop at a young age when they start counting things, when they realize what 5 represents. It represents 5 objects. They start thinking about how numbers relate to each other. Is 5 greater than 4? And how those numbers connect. And that builds as they learn more and more into math fluency. That's getting into operating with the numbers flexibly and efficiently. And those two things are important. We don't want to really stress speed, even though that will come the more they practice. We want to stress that they need to be flexible. And the only way to be flexible is to have lots of strategies. And when you have lots of strategies, then you can pick the one that's the most efficient. So let's look here, because a good way to describe what number sense and fluency looks like is to kind of show what it doesn't look like. If you show a lot of middle schoolers these problems, how many of them would reach for a calculator immediately? A lot. Or would they do a standard algorithm where they're trying to, add 1 plus 1 and get 2 over 2, and then they would reduce it? It's not that that's bad, but all of these problems here, if students just stop and think, they could figure them out pretty quickly as long as they have some number sense about fractions. And they have that fluency with the operations if they can think about them and come up with a solution. Now watch this. How many times have you seen a student do something like this? So this student obviously got the right answer, but it's kind of silly what they did. They're so caught up in doing an algorithm that they didn't even really think about the problem. So when middle schoolers get to us and they lack fluency and we see it, we have some choices. And these things coming up are things that I've done. So I'm not judging anyone. I'm just kind of going through what I've experienced myself and what I've seen other teachers kind of go through as far as what do I do? My students, they don't have the fluency to do these operations. So our first choice is just ignore the problem. This may be what you're feeling like when you feel overwhelmed. Oh my goodness, look at all the standards I have to cover, and my students are not very fluent. I don't have time to do it all. Just hand them calculators. Another thing we could do is try to motivate them to learn math facts on their own. And what this usually looks like is giving time tests. So I've been there too, where I say, okay, we're going to give a times table test, so you need to go practice, and then you need to come back and show me that you know these answers. And I realized pretty quickly that that didn't motivate my students, that they didn't get much better. But now that I've also researched more, I've also seen how that's really not best practice. Time tests do all sorts of things as far as give students math anxiety, and it's just really not the best way to try to teach them fluency. Okay, so we could give them tricks to try to help them remember. And when I say tricks, this is different than a strategy. A trick is something that works maybe for one problem. A trick gets a solution now, but it can't really be used in other situations. So that's the problem with a trick. It may work right now, but it's not going to further their understanding. They really don't know why the trick works. It just gets them an answer to that one problem. And so our other choice is to devote the time to help them learn. And that's of course what I'm recommending in this session. And that's what I think we have to do. If we really want students to grow in their fluency, then we have to go ahead and plan to devote some time to help them. And part of doing that comes from having this belief that students have the ability to reason with numbers. Sometimes we're given directives from admin or maybe someone in our district that we should just stick to the standards. And I feel like sometimes there's an underlying message that, hey, you're going to have some students who just aren't good at math. Move along, you just got to keep on going. And that is so not true. Every student just needs someone to show them how to think about the numbers, how to reason with the math. And you can be that teacher that does that. We know that they can grow in their fluency if we just help them learn how to think. All right, so let's get into some of these strategies. Let's look at what it may look like to do mental math. So I want you to participate. It's always good to kind of see what our students feel as they're sitting in their seats. So I'm going to show a problem, and I want you to do it mentally. And so I will pause for a minute once the problem appears, and then we'll talk about some different ways that students may solve this. All right, now as I describe each strategy, I'm going to show a vertical number line. I think the visual helps to explain the reasoning. All right, so one student may say, I started with 92, I subtracted 60, that gave me 32, and then I knew I needed to add 3 back. And so I got a solution of 35. Another student may say, I also started with 92, but I subtracted 50. That left me with 42, and then I subtracted 7 more, giving me an answer of 35. Another student may say, I did something similar. I started with 92, and I subtracted 50 as well. That gave me 42. Then I subtracted 2, giving me 40, and then I subtracted 5 more, giving me 35. Okay, another student may think of it a little different. They may think of it as, how do I start with 57 and work my way up to 92? So starting at 57, I add 30, which brings me to 87. And then I knew I needed to add 5 more to get to 92. So together, 5 and 30 give me a solution of 35. All right, this next student may say, well, I thought of it as a distance. I thought of the distance between 92 and 57. And since that's a little difficult, I made it a different problem with the same distance. So to make it a little easier but keep the same distance, I added 3 to both numbers. So the distance between 95 and 60 is easy to calculate in my head. It's 35. And since both distances are the same, both differences are the same. They're both 35. All right, and then another student may say, well, I just looked at place value. First, I looked at what's in the tens place, and I subtracted 90 minus 50. That gave me 40. Then in the ones place, I subtracted 2 minus 7, giving me negative 5. And 40 and negative 5 together gave me 35. So you notice these are a variety of strategies, and this is not, there could be many more. This is not an entire list of every strategy. But what's neat about strategies is that they can be applied in other situations. So let's look at a subtraction problem with decimals. Again, I'm going to show it, and I want you to try it mentally first. All right, showing a number line again, the first student may say, I started at 7 and 5/10. I subtracted 2. That gave me 5 and 5/10. Then I subtracted 5/10, giving me 5. And then I subtracted 3/10, giving me 4 and 7/10. Another student may say, I thought of it as distance again. So the distance between 7 and 5/10 and 2 and 8/10, that's a little tricky to think about, but I can maintain that same distance by adding 2/10 to both numbers, making 3 and 7 7/10. And then that distance is 4 and 7/10. And then another student may say, I used place value. So I did 7 minus 2 to get 5. 5/10 minus 8/10 gave me negative 3/10. Together, that made 4 and 7/10. So this is a problem that if you show most middle schoolers, they don't think they can do this mentally. They've never even tried. If anything, they know an algorithm to go to. They've been taught how to subtract decimals using the standard algorithm, and that's what they go to. But they've never even tried to just think about the relationship between these numbers and figure it out in their head. So I want to point out something here. These strategies can be used with decimals, fractions, even integers. So think about around 7th grade when students have a problem like this. How might they use that distance strategy and come up with a solution that makes sense to them? So let's take a look. If they think about the distance between 5 and negative 7, they can maintain that same distance by adding 7 to both numbers. Same distance, but an easier problem. Then it's easy to see that distance is 12. That's not usually how we teach integers, but it is another way to think about integer operations. You can add the same value to both of these numbers, maintaining that distance and making it an easier problem, which adds a little reasoning to just change this to a plus sign, which is what most middle schoolers do. So I want you to notice here, a lot of times in math, we talk about teaching conceptual understanding and procedural understanding. And it's great when students have both of these things. But there's something else that is important too. Because think about subtraction. In middle school, most students have a conceptual understanding of subtraction. They know what it means to subtract. They can think about the visual of removing or taking away. They also have a procedural understanding. They know how to do a standard algorithm. They understand that procedure. But what they lack is these two things connected. Do they connect the concept to the procedure? That's a true understanding, when they can explain the steps in a procedure that they're using and relate it to the concept. And that is what they're doing with these strategies, especially when they can show it with a visual like a number line. All right, let's look at a couple more. This time we'll look at multiplication. So I'll show a problem and you do it mentally. All right, for these, I'm going to use area model. I love using area models to show multiplication. So here's our basic idea here with area. If you have a rectangle that's 16 by 15, what is the area inside? All right, so one student may say, I took that 16 and I made it a 10 and a 6. So we're keeping the same area model. And then I multiplied each of those by 15. 10 times 15 is 150. 6 times 15 is 90. Then I can add those together for the total area of 240. Another student may say, I split it up a little differently. I split up the 15 to give me 10 and 5, multiplied each of those by 16. 10 times 16 is 160. 5 times 16 is 80. Add them together to get 240. Another student may say, well, I rounded the 16 up to 20. So I wanted to multiply 15 times 20 first. This area is a little bit larger. 15 times 20 is 300, but I knew that was too much. I knew I had 4 too many groups. So I needed to subtract 4 times 15, which is 60. 300 minus 60 is 240. Then another student may say, I used a strategy called halving and doubling. So I took half of 16 and I doubled 15. And let's show why this works. So we're going to cut the 16 in half here, maintain the same area. We're just stacking these rectangles slightly different. So we have half of 16 for one dimension and double 15 for the other dimension. 8 times 30 is 240. So you can see all of these strategies a little different, but each one works. And again, there are many more that students may come up with. So let's look at how this might work for fractions. So on this next one, you try it out first, and then we'll show a couple strategies for it. All right, one student may say, with the area model, I took 14 times 5 and 14 times a half. So I split the 5 and a half. 14 times 5 is 70, half times 14 is 7. Add them together to get 77. Another student may say I used the double and half strategy. I wanted to double the 5 and a half, and I wanted to split the 14 in half. Okay, so let's show how this may work. We maintain that same area, but one dimension gets doubled, one dimension gets cut in half. 7 times 11 is 77, much easier to solve than working with fractions. So lots of these strategy students might be like, oh, that's so cool. And that is a great reaction. But what's really cool is that we can show them why it works. And it's important to show the why. It's important to try to provide either a visual or some kind of explanation, because then they're more likely to remember it and they'll know when they can apply it in new situations. Because they're probably going to ask, well, does it work when you have this kind of number? And the answer is yes, it works with every kind of number. It may not always be the most efficient strategy. You may need to use a different strategy, but each of these strategies works for whatever number. Talk a minute about thinking versus memorization. And when I say memorization, I mean when students just memorize and do not think about any kind of meaning. Like when they get flashcards or something like that, and they don't really have to think about the math, they are just memorizing an answer. There are a few reasons why that's not the best strategy. For one, when we say students need to learn their math facts, that's not just times tables. That's usually what we focus on, but in reality, we need them to be fluent in all the operations. Another thing, when you tell students, hey, memorize this, that kind of sends the message that this doesn't have a meaning. All you can do is just memorize it. There are a lot of subjects that you do need to memorize things. Math is not one of them. Math has meaning. And then the other thing that we've mentioned before, memorized facts do not get applied in new situations. So if you've just memorized one thing and you know one answer, you can't apply it to other concepts. When students memorize their times tables up to 12, what about when you give them a problem with 13? They pretty much freeze and think they have no way of solving it. But when we encourage students to think, thinking builds flexibility, it allows creativity. That struggle to think of your own strategy, that is learning. If you did those problems back there and really tried to do them with mental math, you probably thought, man, this is really making me think. That's when students say, this is making my brain hurt. And I say, good. Of course, joking, but I think they mean, wow, I really had to think about that. And it builds independence. This is getting them to think on their own, not rely on something that the teacher told them to do step by step. Okay, so let's get to how do I actually implement this? How am I supposed to teach my students these strategies? What I would highly recommend is that you plan out mental math as part of your routine. Either every day do it for 5 to 10 minutes or a few days a week. Because as we know, if we don't plan it as part of the routine, then the year gets going and we get busy and it kind of gets pushed to the side. So plan to do this knowing that it'll pay off. And a lot of teachers want to know, well, what do I do? So I really like the number talks routine. You've probably seen this. It's more often used in elementary classrooms, but it's a great place to start, and you can use the basic routine in a middle school classroom. So here's how I'll kind of go through the steps of how a number talks routine works, but know that you can change this for your class. This isn't some set in stone, has to be done this way. Okay? So usually the teacher displays a problem, and then there's plenty of wait time while the students think. Then volunteers share answers. And this is where you might write wrong answers and right answers. Whatever is shared, you write on the board. Then volunteers explain different strategies they used. The focus here is on the reasoning. Can you explain how to get to an answer? The focus is not on who got the right answer. It's can you explain it? Can we question each other? Can we discuss it and really think about the math going on here? Okay, and then, let me back up. I also want to discuss some struggles and some frequently asked questions, especially if you're just starting this out. I'll tell you some of my own adjustments I had to make. One of the biggest things when I started out, I was all excited about all these strategies, and then I put a problem on the board, and when I asked for volunteers, everyone told me they did the very standard algorithm. They were describing things like I carried the one, I I imagined borrowing. They were not thinking of all these strategies that I had learned about. And so I had to think, well, how do I teach them? Because they don't know them yet. So once all the students gave their different ideas, and it's fine that they use the standard algorithm, once they gave me that, then I would say, well, hey, have you ever thought of doing it this way? And I would show them a new strategy. And little by little, they would see, oh, that actually makes more sense than what I was doing. And it doesn't happen overnight, but if you show them a strategy, some students will pick up on it, and maybe they'll explain it the next day, and you can build off that. So if you have a plan for, I want to show this strategy this week, and you can pick problems that would do well with that strategy, it will slowly build, and the students will see that they can get more flexible with how they're thinking about the math. Another issue that may come up, it didn't happen too much. I was kind of surprised by how into it students were. I wasn't sure if they would like it, but once they saw that students were doing this math in their head, it was like everyone wanted to try to get the answer. So I didn't have too much of a problem with participation. But with older students, there would be days where I'm like, is everyone really trying this? So sometimes I would have them write down their answer just as some accountability. I might also have them write down a little description of the strategy they used. So I know the typical number talks routine involves no writing, but I don't know. In an older classroom, I feel like sometimes that's okay. We just don't want to encourage students to try to write out the standard algorithm and get set in that one-track thinking. There are other things we can do to reinforce what students are learning. One of those is through exploration activities. This could be where you give students a grade level concept and have them work to prove why a certain solution is what it is. So they could work in groups or partners. You could give them something like integer operations. They could use the mental math strategies they've been learning and apply them to integers. And then with visuals like number lines, or you may even get out counters, but they could try to prove why this strategy works. Think of all the things that students do with fractions. Even though in 5th and 6th grade, those are standards, which would be great to do this with, even in 7th and 8th, fractions are still showing up. So getting them to apply the mental math strategies they've learned for whole numbers to fractions and decimals, that could get really interesting as they try to draw visuals and prove why they work. Another thing to keep in mind is to try to do frequent non-calculator activities. So anytime you can do a lesson and students don't have to have a calculator, don't let them. Anytime that calculator is sitting there, in my experience, students will go to punch things in as simple as 1 + 3. So if we can take the calculators away, that will just reinforce that, hey, you can do this mentally, and it will make them have to think about it. So here's some tips you can use. Try to have students lead the discussion. This just reinforces that the teacher is not the one who's going to be doing the thinking. It's on the students. Another thing I love to do is to use visuals. Number lines are a great way to show students thinking. Even if the student doesn't know what visual goes with their strategy, as they tell it to you, try to draw something to represent it. Number lines are great for addition and subtraction. Area models are great for multiplication and even division strategies. And then discuss why the strategies work. Those visuals can help support that discussion, but that's a big thing. Don't let the strategies become tricks. Be sure the students know why. Encourage creativity, encourage students to come up with multiple methods. And then just be sure the students are made to think. Give them difficult problems. You may think, whoa, I don't think students can do this, but hey, just that attempt, just that struggle to trying to come up with a solution, that is growing their brain. That is them learning. So make them think, give them those difficult questions, give them fractions and decimals and integers if you think they're ready to handle it. And what are we looking to see in the end? Because this is something that's hard to measure. We don't really have a test that is easy to track their progress. It's more of what you'll just start seeing in class. You'll start seeing students that understand, hey, math actually makes sense. You'll hopefully see them not applying rules incorrectly. Like when we see students say 1/2 plus 1/2 equals 2/4, maybe when they stop to think, they'll realize that can't be true. And the biggest thing is that I feel like they'll gain confidence in math. When a student does a problem mentally, that is a big boost of confidence that, hey, I can do math. I can do things that are pretty impressive to most people. So before we go, let's make a plan for how to implement this next year in your classroom. First thing, how often will you do this routine? Is it going to be every day? A few times a week? Write it down because that'll help you stick to it. What part of class will you do this in? Will it be how you start the day, how you end the day? I personally really like this right after the bell work. And mental math had a calming effect on my class because everyone had to get quiet and think. So it was a good way to kind of start off each day. How long will you spend? It is important to plan that because you can get carried away and end up spending a lot more time as you get into these discussions. I like to plan for about 5 to 10 minutes. That should give you time to do about 3 problems, just depending on how deep the discussions go. How many problems per day? So I'd say about 3, and those are things that you want to plan ahead, especially if you want to try to relate those to the current standards you're working on, or to try to plan for what's coming up. And then how are you going to make sure that students learn a variety of strategies? So if you fear that students may not know any of these strategies, then just have a general plan for how you can introduce new ones. Then you can plan your problems to suit those strategies. Again, the strategies do work on every problem. It's not always convenient. So if you want to show students the double and half strategy, you'll want to pick numbers that that's going to work well for and that they can see how they can get a solution using that strategy. Thank you all for joining me today. I hope you have found this helpful. I hope you now have the confidence to try some of these things in your classroom to help your students build their mental math strategies and their number sense and fluency. I'd love to connect. I'm on Instagram at rise.over.run. That is where I'm most active with posting math tips and videos and just helpful things for your classroom. I also have a website, riseoverrunteacher.com, and you can find my resources on Teachers Pay Teachers in the Rise Over Run store. Thank you again for joining me. Hope you have a great rest of your summer and a great start to the new year.